Hi guys, my name is Kyle Bond, and today I will be talking about bionic arms. The term bionics refers to the application of biological methods and systems found in nature to the study and design of engineering systems and modern technology. Typically, when someone refers to a bionic limb, they are referring to an electromechanical prosthesis intended to restore the functionality of a missing or incapacitated limb. For this particular device, here on the left, you can see that there is an upper arm section connected to a lower arm segment with what appears to be an elbow-like joint that is actuated with a large motor, with a wrist attached to a swivel, and a hand with movable fingers that are actuated with either small motors or high tensile springs. Now, this is an example of a complex and professional design. But with the advent of 3D printers in the maker community, people are starting to build their own bionic arms, as you can see on the right. Now, what are some reasons an individual would need a prosthetic limb? If an individual has a disease that affects their nervous system or volitional muscle control, such as amyotrophic lateral sclerosis or multiple sclerosis, then they are unable to properly control their limbs. In this case, an external device may aid them in regaining control of their limbs to perform necessary tasks of day-to-day life, like picking up a set of keys, feeding themselves, and generally interacting with their environment. Likewise, if an individual has suffered a traumatic injury or total loss of one of their limbs, a prosthetic limb can help to replace the functionality of their missing limb. So what types of bionic arms are out there? There are two primary types: those that operate on electrical impulses generated by surrounding muscles, also known as myoelectric type bionic arms, and those that are controlled directly from the brain, which are BCI enabled. For myoelectric type bionic arms, electrodes are placed on muscles that can be voluntarily controlled, so when the wearer flexes these muscles, the bionic arm interprets these contractions as different commands to be performed by the arm. For example, for lower arm prosthesis, electrodes can be placed on the bicep and tricep muscles so that when the user flexes or extends these muscles in certain patterns, the prosthesis will move as intended. For example, to raise or lower the arm or to open or close the hand. In addition, for individuals who have lost their limbs via trauma, targeted muscle reinnervation, also known as TMR, can also be used, which essentially reroutes the nerves that used to control the missing limb to another area of the body, like the chest, so that, say, when the user tries to close their hand on their non-existent limb, their chest would flex instead, but this would be remapped by the prosthesis to close their prosthetic hand. For BCI-controlled bionic arms, the arms are controlled directly from the brain and not the peripheral nervous system. To do this, electrodes are placed on the brain, typically invasively, as non-invasive methods do not provide high enough spatial locality for fine motor movement detection, which measure the brain's electrical activity. To move the bionic arm, the user merely thinks about moving their arm, and when they do, a computer attached to the electrodes that are implanted in the brain will be able to sense this change in the user's brain activity and act upon it as the user intended. For example, to move the bionic arm left, the user only needs to think about moving their arm to the left, which is known as motor imagery, and the arm will move left. To do so, the bionic arm's computer is constantly acquiring the brain activity of the user, pre-processing the signal to remove noise and artifacts, extracting features from the signal using something like, say, time window-based FFT, then classifies these features. For example, does this feature mean anything? Does it mean I should move the arm up, down, left, or right? And then the computer finally instructs the arm to move based on the results of this classification procedure. Now I would like to show you a video of some currently in development bionic arms that I think you'll find fairly interesting. Okay, this video is a little long, so I'll just give you a quick background on it. This is a 60 minutes episode titled Breakthrough Robotic Limbs Moved by the Mind. In this video, this woman here, her name is Jan Schurman, and she has a disease called spinocerebellar degeneration and has lost all volitional muscle control from the neck down. She has just joined the Revolutionizing Prosthetics program as a test subject and is about to have an electrode array implanted into her brain so she can use a new prosthetic arm developed by the Johns Hopkins Applied Physics Laboratory.
Marks here in your hair.
The procedure was done by University of Pittsburgh neurosurgeon Elizabeth Tyler Kabar, who showed us that the area that controls hand and arm movement is accessible right on the surface of the brain. What are the dangers?
We worry about if we were to accidentally tear a blood vessel while we're putting them in, that we could cause a blood clot that would collect on the surface of the brain. Probably the thing we worry about the most is the possibility of infection.
I mean, you do have a connection through the skull to the outside world.
Absolutely.
May I have some irrigation?
During the 6-hour surgery, 2 sensor arrays, each the size of a pea, were
So here, this goes to show you the invasiveness of this particular way of implanting electrodes into the brain. So for something like EEG, typically you would have surface electrodes that you would use to measure the brain signals. However, in this case, in order to improve the spatial locality of the brain signals that you're actually reading, so that way you can get the fine motor skills or fine motor movement detection that you need in order to correctly move the bionic limb, you need to have these electrodes implanted very close to the areas of the brain that correlate with arm movement.
placed on the surface of Jan's brain.
Woohoo!
Then they were wired to 2 computer connections called pedestals, the gateways to Jan's thoughts. You know, people are going to look at those pedestals in your skull and they're going to think, that has to hurt. Is it painful? Has it been difficult in any way?
For a few hours after I woke up, I had the worst case of buyer's remorse. I was thinking, oh my God, I had brain surgery. Why didn't anyone stop me? Why didn't they say, Jan, you're crazy? But as soon as the headache went away, that kind of talk went away too.
5 months after the surgery, we came back to see whether she would.
And this is another downside to having invasive electrodes implanted into your brain. As you can see, you have these 2 rather large pedestals that are sitting on top of the head like this. So, you know, it's kind of reminiscent of the movie The Matrix, where they had the plug in the back of the skull where they would actually plug into the matrix. So here it's kind of similar, where they're plugging into the top of the head, I guess. So hopefully in the future they'll actually be able to upgrade these to wireless units, so that way it's not so much of an eyesore to have these 2 basically ports sticking out of the top of your head.
Be able to control the robotic arm with nothing but her thoughts. They plugged her brain into the computer, and this is what we saw.
I could move it up and straight down.
So this robotic arm that you see here is the robotic arm that's actually been developed by the Johns Hopkins Advanced or Applied Physics Laboratory. So this is actually a very high-tech bionic arm that's used a lot for research purposes, and also for like bomb removal robots, because this actually has a very good amount of finger dexterity to actually, say, pull wires out of a bomb and that kind of thing.
And left and right and diagonally, I can close it and open it, and I can go forward and back.
That is just the most astounding thing I've ever seen. Can we shake hands?
Sure.
No, really.
Yeah.
Like, come right over here?
Yes, you come over
Okay.
there. grasp your hand there. There we go.
Oh my goodness. Wow.
And I can do a fist bump if you'd like.
That's amazing. What are you doing, Jan? What's going on in your mind as you're moving this arm around? What are you thinking?
Okay, the best way to explain is raise your arm.
Uh-huh.
Go. Now,
Right.
what did you think about when you did that?
Well, not very much. I do it all the time.
Exactly, it's automatic.
Is that hard work? Are you having to concentrate?
So that demonstration that she just performed is actually a good example of what motor imagery is. It's basically just imagining that you're actually moving your limb, and then based off of that, the computer is actually able to detect that, and that's what it uses to translate basically the phenomena from your brain signal into physical action that can be performed by the robotic arm.
No, it was hard work getting there. I struggled greatly to go up and down at the beginning. Now up and down is so easy, I don't even think about it. Side to side, don't even think about it.
Just like
Just like that.
your arms used to.
Yes.
We asked Dr. Ling, the program manager, where all of this is headed.
I'm old enough to have watched Neil Armstrong take that step on the moon and to walk.
Okay, this guy here is actually Dr. Ling, which is the he's actually the leader for the DARPA's Revolutionizing Prosthetics program. So
Watch Jan do that. I had the same tingles because I realized that we have now stepped over a great threshold into what is possible. And very importantly, what patients can now expect in terms of restoration. This is very important part, not rehab, but restoration of function.
I wonder what your experience with Jan has taught you about the brain and the brain's ability to adapt to new circumstances.
I think it's taught me something really fundamental, and that is we are tool users, and our arms and our legs are just tools for our brain. And so when we give another tool, in Jan's case, a robot arm, she will adapt to that tool to do the things that she wants to do.
Of course, many who could use a robot arm are not paralyzed like Jan. They're amputees, and for them, the project has found a way to connect the arm without brain surgery. 57-year-old Johnny Mathney lost his arm to cancer. Dr. Albert Chi from Johns Hopkins Hospital found the nerves that used to go to Johnny's hand and moved them to healthy muscles in his remaining limb.
Now, elbow extension.
Sensors on his skin pick up the brain signals from the nerves and use those signals to control the robotic arm.
Come here, I want to see you.
So even though the limb is missing, the brain still sends the signals as if the limb was still there.
Correct.
Johnny, it feels in your mind like your hand is there again?
Yes.
As if your arm had never been lost.
Correct.
Unlike Jan, the connection for Johnny runs both ways. Sensors in the fingers send signals back so he can feel what he's touching. Okay, I'm holding the object. You can close on it. To see how well we put him to the test. Hard or soft?
So,
Correct. Very good. Now let's try again. I'm holding the object. Hard or soft?
so.
Yeah, quite right. All right. He got it right every time. Hard or soft?
Hard.
Amazing. The next person to have Jan's surgery will have additional sensors placed in the brain to receive the sensation of touch. Andy Schwartz believes that will help with some of the things that Jan has trouble with.
Okay.
For example, sometimes when she looks right at an object, she can't grab it.
Okay, I'm going to take the cone away. Just go ahead and close
For
it.
sure.
So as soon as I take the cone away, there's no problem. But as soon as I put the cone there, she can't do it.
Why is still a mystery. The progress is
okay, here's another thing that I want to point out. Notice how she was not able to pick up the cone, however she was clearly able to pick up the water bottle. So is this an issue where the object itself is an obstacle, so that prevents her from imagining, say, closing around the object? So that might be something to think about.
coming rapidly. They're working on a wireless version of the implant to eliminate the connection in the skull. And Dr. Jeffrey Ling told us that the lab experiments will one day enter the real world.
We're going to not stop at just arms and hands. I think that it's going to open the way for things like sight and sound. And in my dream that we'll be able to take this into all sorts of patients with stroke, patients with cerebral palsy, and the elderly.
I think when other quadriplegics see what I'm doing with the arm, they're all going to say, "Oh, wow, I wish I could do that."
That's the way I like to get cookies. Awesome, thank you so much.
I just feel very honored to be the one who gets to do it.
Go to 60minutesovertime.com to see the bomb-diffusing robot known as Robo Sally in action.
Okay, so that's the end of that video. Let's get back to where I was. Okay. So where are Bionic Arms headed? What new advances are currently being made to the technology? Recently, DECA, which is the company who invented the Segway, has achieved FDA approval for their bionic arm, which has also been colloquially called the Luke arm because it mimics the prosthetic arm that was shown in the movie Star Wars after Luke gets his hand cut off and he gets a prosthetic limb put in place. So this particular bionic arm, the one that was recently approved by the FDA, not only provides new amazing dexterity for the user, but it also allows them to feel the texture of the object that they're holding. So the good thing about having this ability to feel is that not only does it help restore another sense of touch that they lost when the user lost their limb, but also it now allows them to handle fragile items without crushing them, for example, eggs. So I'll show a video of that.
And concentration, of course. Cannot lose concentration.
Now with previous prostheses, there would just be egg yolks everywhere.
Wow.
Okay.
Good.
Alright. So now, let's see. Okay, so what's the future for bionic arms? Firstly, I can't wait till we have some, really cool bionic arms like this from the video game Bionic Commander, where you just have basically like a little photon cannon type thing. So that's all I have to say on the subject of bionic arms. Thanks for watching, and here are my references.